Hello, it's Elixir Code Girl. Welcome to the third series of running concurrently in Elixir. So in this series, we're going to learn how we can retrieve result of a task using the task async function. So how does this work? So the task async is almost similar to the task.start because they both start a task. The difference is that with task async is useful when we are in need of retrieving the result of the function. So the task async takes in an anonymous function with the zero arity, then returns to you a task struct. So for you to retrieve the result from that task struct that has been returned, you need to use either task await or task.yield. So let's see an example of this. I'm going to the code editor and demonstrate how the task.async works. So first I need to start the interactive shell. I already have a project that I had demonstrated in the first series. So in here, I had defined a function called notify synchronously with async. So the function naming is because of the function naming is meant to differentiate different task functions that we're going to use and explore all along this series. So I'm going to alias this function name first. Then I'm going to call the notify asynchronously with async. So this function, what it takes a number, then asynchronously send a message to that number. So I will create a variable called task because we want to retrieve a result from that task that will be returned. So I'll say send a message dot notify asynchronously with async. Okay, so you can see we have the IO put message async process started. So that means, and then we have the task returned, the task output returned. So this task, the task struct has some information which is important as well. So the first thing we have is the MFA. This represents the module function attribute. Then we have the owner. The owner in this case is the PID of the process that started the task process, and that we can verify by calling self. So I expect this self is returns the PID of the current process or the parent process. So the EX is the current process here, which is which acts as the parent process in our case. And you can see that the PID returned when we call self is similar to the owner. Then we have the PID. So the PID is the identifier of the task process itself. Lastly, we have the ref. The ref represents the process monitor reference, and this is important in case you want to monitor a process. The other thing you could notice is after the task is returned, we had another abort message sent to 123, and that is the purpose that the send message was. That was what the output that needed to be executed when you call the send message function. Okay, so in the next example, I want us to retrieve the result. And remember, I told you in order for you to retrieve a result from a task, you either need to call the task.await or the task.yield. So the task.await and yield both take in a task struct. So we can call task.await and give it the task variable that we already created. So you can see it returns the result. So this result is what we told our send message to return. So if you come to the send message function, you can see that when given a number, it sleeps for like 10,000 milliseconds. I outputs for you a message sent to that number given, then returns for you the status, which is a tuple of an atom, okay, received, and the timestamp. And that is the same what is returned when we call the task.await. Sorry for that. Okay, so what happens when I call task.yield? We have already retrieved the result. Can we retrieve the same result when I call task.yield at the same time? So let's call task.yield and give it a task. I could give us a minutes guess what our answer will be. But okay, let's go. Just a minute. So you consider the task.yield when given a task has returned to us nil. And why is that the case? So the task.yield cannot return you a result once you have retrieved the result from the task. So we can try to see if the task.await acts in a similar manner, then we will create another task and call the task.yield first. So let's call task.await and give it task. Let's wait and see what happens. So this raises an error. When we read through the error, we can see. So what we're told is that it exited, and the exit is because of the timeout. Then we are told to use the task await receive. But that was not the case when we already retrieved the result. So let's cut the task again. Then call task await again. It has exited. And this is because we're shown that the timeout default is 5,000 milliseconds. But I wonder why at first we were able to, why were we able to retrieve the result in the first instance, but in the second instance, it's not working? Okay, so maybe call task and let it be for some time. So I know that the time here, the sleeping time is more than the 5,000 millisecond. But what I'm curious about is why we were able to retrieve that result at first. So I will call task and just wait for some time for the process to be complete. Okay, so the message sent to 123, so that is an indication that the message has been sent. So let's try to retrieve the result again. We have the result. So what I can notice here is that we tried to retrieve the result before before the process had completed. That is one thing. So let's say if task.yield acts in a similar manner, don't wait for the process to be completed and call task.yield. Okay, so with the task.yield, we receive the result. Let me try again. Task, then call task.yield immediately before. So with the task.yield, it acts like it's waiting for the task to be returned. Now that process has been completed. So once we receive the message sent to 123, that means the process has been completed. So what happens? Let's call the task.yield again. Yeah, we have our result back. So unlike the task.await, which exits if the process is not complete, the task.yield will return you nil if the process is not complete. And once it is complete, you get the result back. Does the task.await acts in a similar manner? Let's create our task again. Task.wait, we're expecting it to exit. Okay, then message has been sent. That means the process has been completed. I will call task.await again. Okay, so now there's a timeout and it's not returning the result for us. But if we call task, then wait for some time before retrieving the result. Then call task.await, we get the result back without having the timeout. So we shall explore the task.await and task.yield in the next series. So now let's only focus the task.async and how to retrieve the result back. But with this short exploration, it's already interesting to see how both works and how both can be incorporated and why to use one and not another, or why you can prefer using either await or using either yield, depending on your use case. Next, I want us to see what happens when you process a task that is resulting to an error and we want to retrieve that result. So I'll just clear this first. Now I want to create a task and deliberately introduce an error. So in this task, I want it to have to compute something that will fail. So that is compute an integer with a string. So that I'm sure it will raise an arithmetic error. So I'll create a variable task again. Here's the task data sync. So the interesting thing with Elixir is that you can notice that the variable name that I'm creating the task is similar to what we created initially, but this task variable will override the previous one. So this will be like a different, the task here will reflect a different information compared to the first one. So I'll do function plus none, then end that. So you can see we have the task struct returned, and we also have an arithmetic error raised. So this task has a computation that raises an arithmetic error, causing the parent process to die. And how can you notice that the parent process has died? So the first thing to notice is that we were using the interactive shell, which was labeled number 18. Now here we are at interactive shell 19. The other thing, if we check our error message, we are told that the task 149 started from the task with the PID 0.149.0 started from the PID 0.141.0 terminating. So that means the task itself has been aborted. The other thing is if we call self, we have a different PID from what the owner that was responsible for the task. So the owner here was 0.141.0, and now we have another parent process which is 0.150.0. So that means the parent process has died, and if we call the task, we can't see the variable. The variable does not exit, which indicates that the task was aborted as well. So if the parent process dies, it means the task will be aborted also. And this is because when you start a process, this process will be linked to and monitored by the parent process. So if the parent dies, the child even dies in this case. So that's all for today's series, and thank you for watching the series. In the next series, we shall look at the difference between the task await and the text detail and explore more on it